Now we need to subtract a multiple of 100. So if we highlight our hundreds digits, we have 8 minus 5. So our hundreds digit will change to a 3. All of our other digits will stay the same. So our answer is 49,382. Now we have 10,191 minus 500. But here, if we highlight our hundreds digits, 5 is more than 1. So what we need to do when this happens is highlight digits to the left as well. But in this number, to the left, we have a 0. So we need to go all the way over to our 10,000s digit, and then we have 101 minus 5. That's 96. So our answer is 9,691, because 101 minus 5 is 96, and then our tens and ones digits stay the same because we're not subtracting any tens or ones. So here we have 284,529 minus 800. If we highlight our hundreds digits, 8 is larger than 5. So let's highlight the place value to the left as well. That means we have 45 minus 8. That's 37. So these digits here will be replaced with a 3 and a 7, and all of our other digits will stay the same. So our answer is 283,729. Now 100,394 minus 600. If we highlight our hundreds digits, 6 is more than 3, but we go to the left, we have a 0, and we go to the left again, we just have another 0. So we need to go all the way over to our 100,000s digits and work out 1003 minus 6. That's 997. So our answer is 99,794, because 1003 minus 6 is 997, and then the 9 in our tens and 4 in our ones stays the same. So let's have a look back at this first question. We started with 49,882, which we've represented here with place value counters. So if we subtract 500, we're just taking away 1, 2, 3, 4, 5 of our 100 counters, and that means the only thing that's changed is that we now only have 3 hundreds. But then we had 10,191, which we've shown here, but we needed to subtract 500. Now we can subtract 100 counter, but then to get more 100 counters, we need to exchange. We can exchange our 10,000 counter for 10,000 counters, and then we can take one of those 1,000 counters and exchange it for 10 hundreds. So remember, we'd already subtracted one of our hundreds, so to subtract 5, we need to subtract 4 more hundreds, and that gives us 9,691. So that's why our thousands digit changed as well, because here we needed to exchange. Then we had 284,529, which we've shown here using place value counters. We needed to subtract 800. Now we can subtract 500 counters, then exchange, then subtract 6, 7, 8, so that leaves us with 3 in our thousands and 7 in our hundreds. So that's why our thousands and hundreds digits changed. We did 45 minus 8 to get 37, and that told us that we would have 3 thousands and 7 hundreds after we'd subtracted 8 hundreds. Then we had 100,394. We needed to subtract 600. We can subtract 1, 2, 3 hundreds, but then we need to exchange our 100,000 counter for 10 10,000s. Then we can take one of those 10,000s and exchange it for 10,000s, and then take one of those thousands and exchange it for 10 hundreds. So remember, we've already subtracted 300 counters, so we need to subtract 4, 5, 6, and that leaves us with 9 10,000s, 9,000s, and 700s. So that's why working out that 1003 minus 6 was 997 gave us our answer, because of course our tens and ones have stayed the same.